In the 1920s, Heisenberg, de Broglie, and Schrödinger, some big fellows in quantum chemistry, developed quantum mechanics. Consider the following statements with respect to this model, entirely conceptual type question, guys. The position of electron can be exactly found and measured. No. That is the Heisenberg uncertainty principle. It's one of the strangest phenomenons in the universe that is known to be true. It's just really strange, guys. You cannot know, it turns out, anything exactly where it is. Now, it's so small, that uncertainty is so small, right? That uncertainty is defined by Planck's constant, right? Planck's constant 6.626 times 10 to the minus 34 joules per second. If that 10 to the minus 34 was 10 to the minus 29 or something larger, life would be very different. We'd have a very uncertain existence in terms of where things are and how fast things are moving. Basically everything. That dictates everything. So one is incorrect. With the use of modern instruments, science can watch an electron move from point to point in its orbit. No, that's for the same reason. You can't know exactly where anything is, including an electron. That's why we have orbitals, not orbits. Those are probability maps, because there's always some probability associated with it. Energy levels in quantum mechanics are not limited to discrete level values, but are actually continuous. Oh man, I hope that you knew that that one was wrong, because this was all what I was talking about in the videos, how life is like stairs. And actually the very first, last day of class, I did get to tell you that. Life is actually like stairs. It's not like a ramp. The stairs are so small that day-to-day life looks like a ramp, but it's not, okay? It's not continuous. It's discrete. Very weird. Quantum mechanics is weird, guys. It's awesome, though. Electrons can get excited to high levels. They do that when they absorb energy. Yes. You're going from a higher energy level to a lower energy level. You're going to have to put energy in to do that, right? And they emit light when they relax energy. Yeah, you went from a high energy to low energy. That's going to let energy out, and that energy could be in the form of light. So the answer, and I really like this question, is number 4. 23, hydrogen sulfide, fun question, smells like rotten eggs. I've smelled it before. So have you, if you've cooked eggs that are a little nasty, or you've been to Lassen National Park, or you've been to Yosemite, somewhere with a lot of thermal geyser activity. Actually, just outside of Mount Rose Wilderness in the Steamboat Hills off of 395, there's some geysers. You've probably seen them. I haven't smelled those. I haven't gotten. It's a geothermal power plant, so I haven't gotten close enough to smell it. But anyway, hydrogen selenide smells even more irritating and strongly of rotten eggs. It smells terrible. Using your knowledge of periodic trends, how do you expect hydrogen livermoride, H2LV, to smell? Well, look, this is the smelly trend. We went from top to bottom, and it's getting smellier as we go to the bottom. So using our periodic trends, we would expect it to smell worse. Last one, which of the following Lewis dot structures is correct for francium chloride? Francium chloride, guys, we have a metal on the left of the periodic table, going back to basics, and a non-metal on the right of the periodic table. This is going to form ions. That one's wrong. Yes, it follows the octet rule. It looks okay, right, for chlorine, but that's wrong. It's not ions. By the way, it doesn't follow the octet rule for francium, so it's a little puzzling if you chose that one anyway. So we need the one with the dot structure, and so that's going to be B. I'm sorry, that's not B. Why is that not B? That is not B. This one doesn't have any dots, so that's wrong. This one has dots, but yeah, francium has one valence electron when it's neutral, but it gave up an electron to go to chlorine, right? This electron wasn't there when it formed the bond. The difference in electronegativity was so great it formed an ionic bond, another way of saying it, right? And so it's going to look like this. Francium with no valence electrons has an electron configuration the same as radon, noble gas configuration, and chlorine, gained an electron from francium, has the same noble gas configuration as argon. So D is your final answer.